In this video, we're going to go over some practice problems from our textbook from sections 1.1 through 1.3. So starting with question 7 here, which equations are linear equations in X? Now remember, a linear equation in a variable will involve only real numbers and only that variable raised to the first power. So in this case, we're looking for equations that are linear in X. So these equations will only involve real numbers and our variable X raised to the first power. So let's look at this first one here. We have 3x plus x minus 2 is equal to 0. Well, notice this isn't fully simplified. What we're going to do is just combine like terms here. We have 3x plus x. This is going to give us 4x's, and then minus 2 is equal to 0. Now, we don't need to solve. We just wanted to simplify to make sure that this is a linear equation in x, just to make sure that we have x raised only to the first power. Now, since we have that, we know that this is going to be a linear equation in our variable x. Now, for part B, let's look at this guy. We have 12 is equal to x squared. So automatically notice that our variable x is raised to the second power. And because of this, this is not going to be a linear equation. So we're going to say non-linear. All right. Let's look at part C here. We have 9x minus 4 is equal to 9. Now, in this case, we could simplify this a little bit further as well if we wanted to. We could add 4 to both sides of this equation. This would give us 9x is equal to 13. Right? If we wanted to do that, we can, or we can just automatically recognize that these are all real numbers and our variable x is raised to the first power here. So this is going to be a linear equation in x. And then lastly, for part D, we have 3x plus 2y is equal to 6. Now, at first, you might think that this is a linear equation in x because we have our variable x raised to just the first power. But notice we also have this variable y here. So remember, a linear equation in x will only involve that variable x raised to the first power. So due to this, since we have a second variable y here, this is also going to be a nonlinear equation in x. All right, so for the next three questions here, we want to solve each equation and check the solution. And if applicable, tell whether the equation is an identity or a contradiction. Now, I believe all three of these are neither. Remember, an identity is an equation that's true for all values of our variable. And then a contradiction is an equation that has no solutions. And all three of these are actually neither, but just keep that in mind for other homework questions. All right, so let's look at 19. We want to solve this equation, so we're trying to isolate our variable x. Now notice what's happening to x is we have this multiplication by 7, and then we're adding 8 here. Now if we want to isolate this, we have to undo what's happening in kind of the reverse order of our order of operations. So we're going to have to take away this plus 8 first. So we're going to subtract 8 on both sides of our equation. These guys are going to cancel out, and we're just left with 7x by itself on the left-hand side of our equation. And then on the right-hand side, we have 1 minus 8. So this is going to give us a negative 7. Now we still need to completely isolate x. We still have this multiplication by 7 here. So to undo this guy, we're going to divide both sides of our equation by 7. Doing so, these guys cancel or reduce to just 1. So we're just left with x by itself on the left-hand side, which means we have fully isolated this guy. And then on the right-hand side here, we have negative 7 divided by 7. This is going to give us a negative 1. All right, now we do want to check that this is a solution to this equation here. And we do that just by plugging in this value that we got for our variable back into our equation. So let's do that. We're going to plug in this negative 1 into our x there. And just make sure that this is, in fact, a true equation here. So we're going to have 7 times negative 1. That's going to give us a negative 7. We're going to add 8 to it. Now notice negative 7 plus 8 is in fact 1. So we have 1 is equal to 1. So that is a true statement, which means this is a solution to our equation. All right, let's look at question 23 here. We're going to do the same thing. Now this one's a little more complicated. Notice we have 3 terms on this side, 2 terms on this side. So let's see if we can simplify this a little bit further. Now notice we have a 7x here and a minus 5x. So we can combine like terms. This is gonna, since we have 7 x's and we're taking away 5 of them, we're just gonna be left with 2 x's. Now, in the same step, I'm also gonna subtract 15 on both sides of our equation here because we wanna bring all of our variables to one side of our equation and all of our constants to the other so that we can easily isolate our variable x. Now doing that, I'm going to be left with just this 2x on the left-hand side, right? We combine like terms here, and then we're moving this guy over. Now on the right-hand side, notice I still have this x, and then we have 8 minus 15. So this is going to give us a -7. Now, like I said, we want all of our variables on one side of our equation, so we still need to move this x over. Doing so on the left-hand side, we're going to have 2x, and then we're taking away one of those x's. So that means we're going to be left with just x by itself on the left-hand side, and on the right-hand side, we have this -7. We always have to bring this sign with us. All right, now again, we want to check to make sure that this is a solution. Now, whenever we're checking to make sure that we have a solution here, we always want to plug in the solution into our original equation here, just to make sure that we simplified correctly. So let's plug in -7 into our original equation. So we're going to plug in -7 there, there, and then again on the right-hand side. All right, doing so, we're going to have 7 times -7. This is going to give us a -49. Then here we have a -5 times a -7. Remember, a negative times a negative here is going to give us a positive value. So we're going to end up with +35 here. And then we're adding 15 to that. And on the right-hand side, we have 1. Now notice -49 plus 35 plus 15 is in fact 1. So this is a true statement. And we know that this guy is going to be a solution to our original equation here. Now, the last one we're going to look at for these problems here is 38. We again are trying to isolate x. Now, this guy is a little more complicated than the last two. We're going to have to use our distributive property and then simplify just like we saw in the last problem. Now, when we're using our distributive property, this -3 here is multiplying everything inside of our parentheses. So we're going to distribute this value of -3 to both terms in our parentheses. And on the right-hand side of our equation, we are going to do the same with this 4. All right, so doing so, we still have this 6x here, and then we have -3 times 5x. When we're multiplying these guys, we're going to multiply the coefficients or the numbers here in front of our variable. So we're going to have a -3 times 5, which gives us a -15x. Then we're distributing this -3 also to this 2 here. So this is going to give us a -6. And on the right-hand side, we're going to have 4 times 1, which just gives us a 4. And then we have 4 times a -x. So that'll give us a -4x. Now from here, this problem becomes very similar to the last one we saw, this 23 here. So we're going to do something similar. We're going to be combining like terms and then moving all of our variables to one side of the equation. So notice we have a 6x and a -15x here. So we're going to combine these guys to get a -9x. And in the same step, just like we saw in the last problem, I'm going to move this 6 over. So doing so, we're going to have -9x by itself on one side of the equation. Then we're going to have 10 because we have 4 plus 6. And then we still have this -4x. Now, moving all of our variables to one side of our equation, we're going to have to move this 4x over. These guys are going to cancel. And then we're just going to be left with -5x is equal to 10. Now from here, we just have one more step to completely isolate this x here. Now notice what's happening is we're multiplying this x by -5. So we are going to have to divide by -5. We can't just divide by 5. Doing so would leave a negative in front of this x, and technically it wouldn't be completely isolated if we had a negative sign in front of it. So doing that, we're going to get x completely isolated here, and then we have 10 divided by a -5. So this is going to give us a -2. Now we do want to check the solution. So in the interest of time, I'm going to have you guys check that one on your own. So the next three questions here, we're again solving each equation, but now we're dealing with fractions. So looking at this first one here, we have 6 over 5x is equal to -1. So what's happening here is we have 6 over 5 multiplying x, or another way to think of this is that we're multiplying 6 times x and then we're dividing that by 5. So what we can do to undo this here is we can first multiply both sides of our equation by this 5 here. So we're kind of undoing this division by 5. When we do that, these guys are going to cancel, and we're just left with 6 times x on the left-hand side and then -5 on the right-hand side of our equation. Now, to fully isolate our variable, we need to divide both sides by 6. This will give us x isolated on the left-hand side, and on the right-hand side, we have -5/6. So this is our potential solution for this equation here. So in order to check this, we're just going to plug in this value that we got for x directly into this guy. We're going to get 6/5 times -5/6. And we want to make sure that this is in fact equal to -1. Now, notice we have a 5 in our denominator here, a -5 in our numerator. So these guys are going to cancel and leave us with this negative. And then we have a 6 in our numerator and a 6 in our denominator. So these guys cancel and these guys cancel. And we're just left with a -1 on the left-hand side. So this is a true statement. So this is, in fact, a solution to our original equation. Now, moving on to this next one here. In this case, we're going to be doing something similar, but now we need to distribute this fraction here. So this 1/7 is going to be multiplying everything inside of our parentheses here. This -1/5 is going to be multiplying everything in these parentheses as well. So I'm going to leave a space here, and you'll see why in a minute. When we distribute these fractions, we're going to end up with 1/7 times 3x. Then we're going to have 1/7 times 2. Then we have -1/5 times x. So we have -1/5 times x. And then we have -1/5 times 4. So this is going to be -1/5 times 4. And then on the right-hand side, we just have this 2. Now let's try to simplify this a little bit further. 1/7 times 3x is going to be the same thing as just 3/x times 7. Similarly, we have 2/7 x/5, and then -4/5. Okay, so just simplifying this a little bit further. Now, before we can combine any like terms, we're going to have to find the least common denominator for the values in our denominator here, so 5 and 7. Now, we abbreviate this with LCD. So the least common denominator of 5 and 7, this is going to be 35. Now, if you can't look at these guys and automatically know this, what we can do is list out the multiples of 5 and 7. So for example, we can multiply 5 by 1. This will give us 5. We can multiply 5 by 2. This will give us 10. And we're going to repeat this process all the way up to 5 times 7. This gives us 35. Now we have to do the same thing for our other number here. We're going to get multiples of 7. So we're going to have 7 times 1, 7 times 2, all the way up to 7 times 5. And the reason why we're doing this is we want to find a common multiple between these guys. 5 times 7 gives us 35, and 7 times 5 gives us 35. So this tells us our least common denominator here is going to be that multiple, that 35 there. Now we need to find the least common denominator because we're going to multiply everything in this equation by that LCD. And when we do this, a lot of things are going to cancel. So actually, before we do that, let's try to simplify this a little bit further. Notice this 3x/7 and this 2/7 have the same denominator, so we can combine them. And similarly for these two terms here, both of them have a denominator of 5. So combining them, we're going to have 3x plus 2/7. And then we're going to have this minus sign here. We're going to have a minus. And when we do that, we're essentially pulling out a minus sign from both of these terms because we're trying to combine them into one. So if I pull out a minus sign from both of these terms, we're going to have a minus on the outside, and this is going to end up being positive. So we're going to have x plus 4 in our numerator over 5. All right. So what's happening here when we kind of combined them, we can think of this guy as an expanded form of this guy. If we were to re-expand this guy, this negative would have to be applied to everything in this numerator here. We can kind of think of this division bar or this fraction symbol as a grouping term. So these guys are grouped together, and if we want to expand on them, this minus has to apply to everything. We're subtracting this entire guy. All right, so from here, we can multiply everything by our least common denominator. We know that that's going to be 35. So we're multiplying everything by 35. When we do this, we're going to have 35 times 3x plus 2 over 7 for our first term. And then we're going to have 35 times x plus 4 over 5 for our second. And then on the right-hand side, we'll just have 70. Now, you'll see why we're multiplying both sides of our equation by the LCD. Notice we have 35 in our numerator and 7 in our denominator. We can divide these guys out, and when doing so, we're just going to be left with 5 here. And similarly for our second term, we have 35 divided by 5. So these guys are going to cancel, and we're just going to be left with 7. So our equation becomes 5 times 3x plus 2 minus 7 times x plus 4 is equal to 70. So by multiplying both sides of our equation by this least common denominator, we got rid of these fractions. Now we have to multiply by the LCD because we know that these denominators are definitely a multiple of our LCD. We know that these guys are going to divide nicely. Okay, so from here, we're just going to simplify this and solve for our variable. So notice we're again going to use our distributive property on both of these guys here. So this 5 is going to be distributed to this term and this term, and then negative 7 is going to be distributed to both of these guys. So we're going to have, we're kind of running out of room, so let me zoom in here. We're going to have 5 times 3x. This is going to give us a 15x. Then we're going to have 5 times 2, which gives us 10. Then we have negative 7 times x, so that'll give us a negative 7x. And then we have negative 7 times positive 4, so we're going to have a minus 28. And on the right-hand side, we still have this 70. All right, so now let's combine like terms and simplify. Notice we have a 15x, a minus 7x. We can combine these guys, and then we have a plus 10 and a minus 28. So we're going to be left with an 8x, combining our 15x and subtracting out 7 of them. And then we have negative 28 plus 10, so this will give us a minus 18. And again, we still have that 70 there. Now we want to completely isolate x, so let's add 18 to both sides of this equation here. Doing so, we're going to end up with 8x is equal to 88. And then our last step for isolating this variable is we're going to divide both sides of this guy by 8. Doing so, we're going to get that x is equal to 11. Now, in the interest of time, and since I'm running out of room here, I'm not going to check this solution, but make sure that you guys do. Just take this guy and plug it into our original equation here. All right, let's look at this last one here. So same idea, we're dealing with fractions in this case. So what we want to do to get rid of these fractions is find the least common denominator and multiply both sides of our equation by that LCD. So the LCD of 4 and 6 is going to be 12. And again, we can figure this out by listing the multiples of 4 and 6. We know that 4 times 1 is 4, all the way up to 4 times 3 gives us 12. Similarly, we have 6 times 1, which gives us 6, and then 6 times 2 gives us 12. So we can stop there because we found this LCD. So now let's multiply both sides of our equation by this LCD. And remember, if we're multiplying both sides of an equation by something or dividing both sides of the equation by something, it has to be applied to every single term. That's why we see it to both of these guys here. All right, so our new equation then is going to become 12 times that 3x minus 1 divided by 4 plus 12 times the x plus 3 divided by 6. And this is going to give us 36 on the right-hand side. Now from here, again, we can divide these guys out. We have 12 divided by 4, which we know is going to give us 3, and then 12 divided by 6, which gives us 2. So this guy is just going to reduce to this here. And this becomes very similar to the last problem that we saw. We just have to distribute these guys, simplify, and solve for our variable x. So we're going to distribute this 3 to both terms in our parentheses and this 2 to both terms in those parentheses there. This will give us a 9x. We have 3 times 3x, and then minus 3 because we have 3 times this negative 1. Then for these guys, we're going to have 2x plus 6, and we still have that 36 there on the right-hand side. So from here, let's combine like terms. we have a 9x and we're adding two more x's to that. So that'll give us 11 total. And then we have a -3 and a +6. So this is going to give us a +3 is equal to 36. Let's keep isolating our variable x. So we're going to subtract 3 on both sides. That'll give us 11x is equal to 33. And then our very last step here to completely isolate our variables, we're going to divide both sides by 11. This will give us x is equal to 3. Now again, I'm going to have you guys check that solution, but just take this x is equal to 3 and plug it directly into our original equation. All right, so this brings us to section 1.2. Now, for this first question, we're going to be solving an equation for a specified variable. Notice within this equation, we have four different variables, and we want to solve for this lowercase b. Now, like we saw in the last section, in order to solve for a variable, we want to completely isolate it. So we need to do our order of operations in reverse. Notice we're adding this capital B to this lowercase b here and then multiplying by h and 1/2. So we're going to have to deal with this multiplication before we can deal with this addition here. So remember we saw in the last section, if we want to get rid of a fraction, we're going to multiply by this guy that's in our denominator here. These guys are going to cancel. And whatever we do to one side of our equation, we have to do to the other. So we're going to have 2 times a. And then on the right-hand side, we're still going to have this product of h times this b plus b here. Now, the next thing we're going to do is get rid of this h. We can do so by dividing by h on both sides of our equation. We're going to be left with 2 times a divided by that h. And then on the right-hand side, we're just left with what's inside of these parentheses here. So we're going to have this lowercase b plus this capital B. Now, our last step to completely isolate this lowercase guy is to subtract this capital B on both sides of our equation. We're going to have 2a over h, and then we're subtracting b from that. And then we're just left with this lowercase b on the right-hand side of our equation. So this would be our final answer. Now, for this next question here, it's kind of similar. We're told that as of 2021, the highest temperature ever recorded in the state of Washington was 49 degrees Celsius. Now, we're going to use this formula here to find the corresponding Fahrenheit temperature to the nearest degree. Now, I'm saying that this one is similar because notice we're given our equation that Celsius is equal to this, but we're also given our temperature in degrees Celsius. So we actually need to isolate this F here. So we are going to again be solving for a specified variable before we can answer this question, and we're going to be solving for F. Now to do so, we again can multiply both sides of our equation by what we have in our denominator. Doing so, these 9's are going to cancel, and we're going to be left with 9 times C is equal to 5 times degrees Fahrenheit minus 32. Now, again, like we saw in the last example, we're going to divide by 5 on both sides of our equation. These guys are going to cancel, and then we're left with 9 times C divided by 5 is equal to F minus 32. So our last step is going to be adding 32 to both sides of this equation. Doing so, we're going to get this here. So this is our formula for degrees Fahrenheit. Now going back to our question here, we want to convert 49 degrees Celsius to degrees Fahrenheit. So we're just going to plug in our known information. We have 9 times our temperature in degrees Celsius. So this is going to be 49 divided by 5. And then we're going to add 32 to it, and that's going to give us our degrees Fahrenheit. So 9 times 49 divided by 5 is going to give us 88.2. And then we'll add 32 to that. This will give us 120.2 is equal to F. And then we want to find this temperature to the nearest degree. So rounding this is going to be 120 degrees Fahrenheit. All right, so for our next two questions, we're dealing with percent problems. So let's zoom out a little bit. For question 67 here, we're told that Anna saved $1,950, which was 65% of the amount needed for a used car. So with this information, we want to determine what was the total amount needed for the car. Now, in this case, we can use our basic percent equation. So we'll say our basic percent equation. Now, this is given to us in our textbook, and it's our percent, which we denote with P, times B, which is our whole amount, is going to be equal to A, our partial amount. So a percent of our whole amount is equal to that portion of the whole amount. All right, so in this case, 65% of our whole amount, the amount needed or the total amount for the car. So 65% of this total amount is going to give us our partial amount that is saved, the 1950. So plugging in our known information, our percent is 65%, but we know that whenever we are doing arithmetic with percentages, we need to first convert this to a decimal. So this guy is going to be 0.65. So we'll plug that into our equation. So 0.65 times our whole amount, which is what we're trying to find, we know is going to be this much, the amount that Anna saved. So from here, we just need to solve for B to get the total amount for the car. To do that, we're going to divide both sides by this 0.65 to undo that multiplication. When we do that, we're going to be left with B by itself on the left-hand side, so it's completely isolated. And then we're just going to divide this 1950 by 0.65. This will give us 3,000. So the total amount for the car is $3,000. And we can always check our answer, just like we saw in the last section here. We can plug this value back into this original equation, and we will see that 65% of our total amount, which is 3,000, is going to be equal to that portion of this total, which is 1950. All right, let's look at our last question for this section here. So a ticket to a concert was purchased at a discount. So before we read the rest of this, this automatically tells us, since we're talking about a discount, that we're looking at a percent decrease. Okay, so just keep that in mind. So the regular price of the ticket was $70, but it was purchased for 56. So what was the percent discount? Now, whenever we're dealing with a percent increase or decrease, we can use our percent change formula. Now, this is also given in our textbook. So our percent change is going to be the actual change over the original amount. Okay, so our percent change is what we're trying to find is going to be the change in our original and our new values. So that's going to be 70 and $56. So that we're trying to find the difference between these guys. That's going to give us the change. And then our original amount was 70. So this is going to give us 14 divided by 70, which if we plug that into a calculator, we're going to get 0.2, which tells us this discount is 20%. All right, now it's just something to note here is that we could use this equation here to solve this question. We would plug in our total price, which is 70, the portion of it, which would be 56, and then we'd solve for this percentage. But something to note here is that this percentage, if you were to do it that way, would end up being 80%. And that's because 80% of the total, so 80% of this 70 would give us 56. So we just have to be careful of the context of the problem because we're asking for the percent discount. So what you would find is the percent of this whole would be 56, but that wouldn't be the actual marked off amount. The marked off amount would be that 20%. So just keep that in mind. If that is too confusing, then just scratch everything I said and just use this formula here. All right, so this brings us to section 1.3. This is going to be the last section for this video. So for our first three questions, we want to translate each verbal sentence into an equation, expression, or an equality using x as the variable, and then we're going to solve or simplify if we can. So for question 3, 6 is less than a number. Now, our unknown value is this number, so that's what we are going to use x for. So x is going to represent this unknown value. So 6 is going to be less than a number, and that number is going to be x. All right, so that one's pretty simple. We can't simplify or solve for anything. So moving on to the next one, we're told we have the product of 8 and something else. So this is kind of how we can break down these verbal sentences. We have the product of 8 and something. So I'm going to start out with 8, and we're multiplying 8 with this second part of our equation. So the product of 8 and 16 less than a number. Now remember this a number, that unknown is going to be x. So it's going to be the product of 8 and 16 less than our unknown value x. So we're going to have x minus 16 here, and that is going to be our product. Our product of 8 and 16 less than our unknown value x. All right, and then for our last one, if the quotient of a number and 6 is added to twice the number, the result is 8 less than that number. Okay, so let's break it down just like we did for question 11. If the quotient of a number and something else. So we're going to have quotient. So we have our division symbol there. So the quotient of a number, so x and 6. So that's going to be our first term. So this quotient of a number and 6 is added to something. So we're going to have this plus sign, and it's added to twice that number. So it's going to be 2 times our value for x. Now this is going to be, or this result, so we're going to have our equal sign, is going to be 8 less than the number. So we're going to have 8 less than x. Now from here, we can simplify and solve for our variable x. So the first thing that we're going to do is get rid of this fraction. And we know that in order to do that, we just have to multiply both sides of our equation by 6 there that's in the denominator. So doing so, the 6 is going to cancel with this guy. So we're going to have x here. But then remember, we're multiplying both sides of our equation. So it's going to apply to every single term on both sides of our equation. So the 6 is also multiplying this 2x. So we're going to have a 12x there. And then on the right-hand side, this 6 is multiplying this x. So we're going to have 6x, and it's also multiplying this negative 8. So we're going to have 6 times negative 8, which gives us negative 48. Now let's do the rest of it up here. We want to solve for x. So I'm going to try to get all of our variables on one side, and we can easily do that by combining this x with this 12x. This will give us 13x. But in the same step, I'm going to subtract 6x on both sides. Doing that, first combining these x's, that's going to give us 13x, and then subtracting out 6 of those x's, that's going to leave us just with 7x on the left-hand side. And on the right-hand side, we're going to have this minus 48 by itself. Now, again, we want to solve for x, so we know that our last step is going to be dividing by that coefficient of 7. So we're going to have x is equal to negative 48 over 7. And this will be our final answer. Moving on to our next question here, question 33 from our textbook. We're told that the Bermuda Triangle has a perimeter of 3,075 miles. The shortest side measures 75 miles less than the middle side, and the longest side measures 375 miles more than that middle side. So with this information, we're going to find the lengths of all 3 sides. So with these types of problems, the first thing that I like to do is to draw a diagram. So we have, maybe let's not do a right triangle. This is going to be our Bermuda Triangle. Now, notice that this kind of looks like maybe the shorter side, maybe this is the middle side, and maybe this is the longer side. It doesn't need to be perfectly to scale, but let's label these guys. I'm going to call this one the middle side. Then I'm going to call this one the shorter side, and we're told that the shorter side is 75 miles less than the middle side. So the shorter side then, which we denote as S, is just going to be 75 miles less than the middle side. And then our longer side, I'm going to call L, is going to be 375 miles more than this middle side. So for this L, we're going to have M plus that 375. So that's our first step done. The next thing we're going to do is plug in our, or use our given information to create an equation. Now we're told that the perimeter is this guy here. So that means the sum of all 3 of these sides, that's going to be the perimeter of this triangle, needs to equal this 3,075 miles. So this perimeter here is going to be the sum of all 3 sides. We're going to add the middle side plus the shorter side plus the longer side. So plugging in our known information, we're going to have the middle side plus our shorter side plus our longer side. So from here, we can combine like terms and simplify this. Notice we have one, two, three m's. So we're still going to have this guy, but then we have three m's. And then we have minus 75 and plus 375. So this is going to give us plus 300. Now from here, this just becomes an equation where we want to solve for our variable, and in this case, it's m. So let's do that. We're going to subtract 300 on both sides of our equation. This is going to leave us with 2,775 on the left-hand side, and then 3m on the right. And lastly, we'll divide both sides by 3 to give us our middle length. Dividing both of these guys, or dividing this left-hand side here by 3, this is going to give us 925. And then our units in this case is miles. So 925 miles is going to be the length of our middle side of our Bermuda Triangle. Now with this, we can find the lengths of the other two sides. We know that the length of our shortest side is going to be the length of our middle side, so 925 minus 75 miles. So the length of our shortest side is going to be 850 miles. And then lastly, the length of this longer side is going to be our middle side. So that 925 plus 375 miles. This is going to give us 1,300 miles. Right, so that's how we would solve a question using the given information. This is how we would translate these verbal sentences into equations and solve for our unknown values. All right, this brings us to our next question. So in this case, we're dealing with a simple interest problem. So I'm just going to write this down for us. We know that our simple interest formula is the interest is equal to our principal amount times our rate times our time. Okay, so with that, we're told that Peter invested some money at 3.5% simple interest and 5,000 more than 3 times that amount at 4%. Now he earned a total of 1,440 in annual interest. So with this information, we want to figure out how much was invested at each rate at the 3.5 and the 4%. Now, the first thing that we're going to note here is that we're looking at annual interest. So in this case, T is equal to 1. So that simplifies our equation a little bit. But notice we have two different principal amounts, right? We have a principal invested at 3.5%, and then we have another principal amount invested at 4%, and that principal amount is 5,000 more than 3 times the first principal. So we are going to label some stuff so we can keep track of all of this information. I'm going to call the first principal P1, and that is going to be the money invested at this 3.5%. Now, our second principal is going to be the amount invested at the 4%. But notice that this amount that's invested at the 4% is also 5,000 more than 3 times our first principal. So this is going to be an equation. It's going to be 5,000 more. So we're going to add 5,000 to 3 times our first principal amount. So with this information, what we want to do is figure out what exactly P1 and P2 are. So we know that our total interest is this 1440 here. So our total I for interest is going to be this 1440. And we know that this total amount is going to end up being the sum of our first principal times its rate times time plus our second principal times its rate times time. So we're going to have P1 times our rate times time plus P2 times our rate times time, just because we have two principal amounts. So let's plug in our known information. Let's do a step by step here. We're going to have P1, which we don't know what that is, at 3.5%. So remember, we have to turn this into a decimal. And then remember, our time is just 1. So we're just going to put 1 there. And then we're going to have our P2. Now remember, our P2 is 5,000 plus 3 times P1. So we'll plug that in here. We're going to have 5,000 plus 3 times P1 times our 4% or our 0.04. And again, our T is just 1. So let's simplify this a little bit. So this looks more like the equations that we're used to. We have our variable P1, and then this is going to be the coefficient of that variable, which is going to be 0.035, and then P1. And then since this is just a 1 here, we can just leave that as is. And then for this next one here, we're going to have 0.04 times everything in the parentheses here. So just simplifying this so it's a little bit easier to look at and work with. And we can't forget that we have this 1440 on the left-hand side. Okay, so from here, let's start simplifying this. We're going to have this guy as is, but we can distribute the 0.04 to everything inside of our parentheses. And then just something to note here is that I'm going to keep working with these decimal amounts because I'm comfortable with it. It's fine for me. But if you would prefer, you can multiply all of these by a certain power of 10 to get these into whole numbers. Okay? Either way, as long as you're doing the math correctly, you should end up with the right answer. Okay, so with that being said, we're going to multiply 0.04 by this 5,000. Doing that, we're going to get 200. And then we're going to multiply this 0.04 by this 3 times P1. 0.04 times 3 is going to give us 0.12, and then we have P1 there. Okay, so from here, we can start combining like terms. Notice we have a 0.035 P1 and a 0.12 P1, so we can add those guys together. And we can also subtract out this 200 from both sides of our equation so that we have our variable terms by themselves on the right-hand side. Okay, so we're going to have 1440 minus 200. That's going to give us 1240. And on the right-hand side, we're combining these guys. So adding them together, we're going to get 0.155 times P1. So from here, we just need to isolate P1. So we're going to divide both sides by this decimal. Plugging this into our calculator, we're going to get 8,000 is equal to P1. Now remember, P1 is the amount invested at 3.5%. So we're going to have $8,000. Now we also want to find P2, and remember P2 is the amount invested at 4%, and that's given by this equation here. So we can find P2 just by plugging in our value for P1. So we're going to have 5,000 plus 3 times our value for P1, which was 8,000. Plugging this in, this is going to give us $29,000 that was invested at 4%. All right. Now let's move on to our last question in this video here. So we're told that in a chemistry class, 12 liters of a 12% alcohol solution must be mixed with a 20% solution to obtain a 14% solution. So with this information, how many liters of the solution are needed? Okay, so again, let's start labeling some stuff. Let's assign some variables to some quantities here. So X, we're going to call the liters of the solution. This is what we're looking for. So this is the amount of the 20% solution. We don't know how many liters we need yet. And then notice that our total amount of solution, because we're combining 12% with a 20% solution. So this total amount, when we combine them, is going to consist of this 14% solution. So X amount of liters which is what we're trying to find, plus the 12 liters of our 12% alcohol solution is going to give us the total solution. So with this information, let's create an equation. We know that we're going to take 12 liters of our 12% alcohol solution, converting that to a decimal, we're going to get 0.12, and we're going to add X amount of our 20% solution, which is going to give us 0.2. Now, this is going to give us our total amount, so the X plus the 12 liters of our 14% solution. Okay. So with this information, let's start to simplify this. We're going to multiply 12 times that 0.12. That's going to give us 1.44. Now we have 0.2 times x. X is what we're trying to find. And then on the right-hand side of this equation, we're going to multiply, or we're going to distribute this 0.14 to both terms in our parentheses. Doing so, we're going to get 0.14x. And then for the second term, we're going to get 12 times 0.14, which is going to give us 1.68. Now, again, you don't have to work with decimals if you don't want to. You can multiply all of these guys by a certain power of 10 to get a whole number. But what we're trying to do here is we're trying to solve for x. So I'm going to get all of our x terms on one side of the equation and all of our constants on the other side. So to do that, I'm going to subtract both sides of our equation, the 0.14x. These guys will cancel. And in the same step, I'm going to subtract out this constant here on both sides of this equation so that these guys cancel. Doing so, I'm going to have 0.2x minus 0.14x on the left-hand side. This is going to give me 0.06x. And on the right-hand side, we're going to have this 1.68 plus, or sorry, minus this 1.44. So this will give us 0.24. And in the last step, we're trying to isolate x. Doing so, we're going to get x is equal to 0.24 divided by 0.06, which gives us 4. And in this case, 4 liters, since we're looking for the solution of or the amount of the 20% solution here, right? And then for all of these examples, we can take the solution that we found and plug it into our original equation just to make sure that that is in fact a solution. All right, so that'll be it for this video.